Hello, this is Owen Fennessy. Welcome to my presentation on the WeatherTop web app. Today I'll be demonstrating the app and then having a look at some of the code that went into it. But first I want to talk briefly about the progress that has been made on the app. I've completed all items in the specification and have added some extra features and design ideas beyond Release 3 that may be of interest to the company. These have been included in Release 4 of the app. Regarding payment, I feel that everything the company has asked for in the specification and more has been delivered, so I'm hopeful that the payment received will reflect this. Let's now have a look at the app in action. Looking first at the home page, we see a menu bar, masthead, some information about the site and some link buttons. Let's look at the login page. Here I'll log in as an existing user, which will redirect me to this user's dashboard. On the dashboard, we can see all of the stations for the user listed in alphabetical order. For each, we can see the details of the station's latest reading represented on 4 cards. These feature a dynamic icon, date and time of reading, weather condition, Beaufort label, temperature in Celsius and Fahrenheit, Beaufort force, wind direction, wind chill factor, pressure, as well as minimum and maximum recorded temperature, wind speed and pressure, and trend arrows for each. We have a form to add a new station. All fields are required and some checking is done to make sure the values are valid before sending the data to the server. After adding the station, the page is updated with the new station displayed in the correct place alphabetically. We can then delete this station using the delete button, and we can also click on the folder icon to see further information on the station. Let's click on Tremors. Here we can see the station coordinates and a map showing a marker where the station is located. We also see the same cards we just looked at in the dashboard. We have a table that shows all readings the station has taken, displaying the most recent readings at the top. The table displays date and time, weather code, temperature, wind speed and direction, and pressure for each reading. We can add a new reading using the form below. All fields are required in this form and additional checks are carried out to make sure the values are valid before submitting. After submitting, we can see the table and latest reading cards update, and we can now delete this reading if we wish. Let's now click on the user drop-down menu and go to the account settings page. Here we have options to update the name, email and password for the user, as well as an option to delete the user's account. Some checking is done on the server side for many of these updates. For instance, if I attempt to change my email to one that already exists in the database, I'll be given a message saying the update failed because the email is already registered with an account. If I try again using a valid email address, I'll get a success message. Let's now look at the account analytics section. This section wasn't in the spec, but I feel it could be a feature that users find useful or interesting. We're presented with the join date of the user, a field I've added for each user in the database, as well as the count of stations and readings, the number of days the user has been active, and the average readings taken per day. Let's log out this user, which will redirect us to the home page, and we'll sign up a new user. Similar validity checks are performed here. If the email already exists in the database, the sign-up will fail and will be redirected to the sign-up page. All fields are required here too. After signing up, we're redirected to the new user's empty dashboard. If I go back to the home page, you can see the menu stays in the logged in state, unlike earlier where we were given options to sign up and log in. If we go to the About page, we can see some information on the company accompanied by some images. The app has been deployed on Heroku, and you can see on GitHub that we have a commit history as well as tagged releases. Let's now look at some of the code. The web app follows the model view controller pattern using the Play framework with Java. HTTP requests are routed to methods in controller classes, which then often interact with model classes to create, read, update, and delete data from the database. The controller class then typically renders a HTML view, often passing in data gathered from the model to be used by the templating engine that renders the HTML page. After rendering, the HTML page is then sent to the client. A typical example of this pattern in the WeatherTop app can be seen in the code used to render the user dashboard page. Upon receiving from the client a HTTP GET request with a /dashboard URL, the corresponding controller method for this URL in the routing table is called, in this case the dashboard.index method. This method first retrieves data from the database by instantiating a new member model object. It then performs some operations on this object, sorting and retrieving a list of stations, calling methods to update latest readings and analytics for each station, before finally rendering the dashboard.html view, passing to it the stations list it has retrieved. In the view, the templating engine loops through the list of stations, rendering HTML elements using properties from each station. Looking at the data model of the app now, the three entities stored in the database are the member class, which contains a list of stations, the station class, which contains a list of readings, and a reading class. The station class also contains two transient objects, meaning they are not stored in the database. These transient objects are instantiated from the station analytics and detailed reading classes, the latter of which inherits from the reading class. These transient fields allow the data to be tightly contained within the station class, making it somewhat easier to pass data to the views. However, on reflection, I think that keeping these separate from the station class and instantiating them as needed, similar to what I have done with the member analytics class, would have been a stronger design. Other things to note in the model classes are the email property's unique constraint annotation, which throws a persistence error if the user tries to add an email to the database that already exists. I've included error handling for this in the relevant controller class methods. There is also an order by annotation on the readings list in the station class. This returns the readings sorted by descending date when they are retrieved from the database. This means that most recent readings will be at the start of the list, which is reflected in how they are displayed in the readings table. For the sort stations method in the member class, I've used the list.sort method, where I've defined a lambda function as its argument. This function takes the two stations for each comparison the sort method needs to carry out and compares their names using the compare to ignore case method. The detailed reading, station analytics, and member analytics classes contain many methods for performing conversions and calculations on data. I've kept many of these methods as static methods, as they may become useful elsewhere in the future of the app. Many of the controller methods contain checks to ensure that the logged-in user has permission to add, access, modify, or delete data from the database. The typical procedure for these methods is to check if there is a logged-in user. If there is one, check if they own the data trying to be accessed, and then either perform the request or handle the cases where the checks fail. Looking now at the views and the use of the templating language in the app, all views extend the base layout of main.html, where I've included a link to an additional style sheet, mainly used for small changes to the Fomantic UI styles, like adding extra padding and margin, increasing font sizes, etc. For forms, I've included HTML attributes to the input elements to perform validity checks before sending data to the server. These include min and max attributes, which prevent values outside of the range specified being sent, step, which only allows values that are a multiple of its own value to be entered, and the required attribute, which prevents submission of a blank field. I've used some if statements in the views, such as here in the account settings view where a message displays if one exists, and here in the about page where I display different menus depending on whether or not the session contains a logged in member. I've used in the views methods to format numbers and dates, such as the round method and the toLocalString method. I've also included a Fomantic UI drop-down menu, adding a line in the script element to make this possible. I've also added a simple map to the station view by adding variables to an OpenStreetMap URL. Probably better ways to do this using other technologies, but this was straightforward and required no JavaScript or API keys. Also, please excuse the indentation here. This is the cleanest way I could figure out to make this URL readable. That's about all we have time to look at now. Thank you for watching.